So in APM 105, it is a course that is focused on applications. So we will be spending a decent amount of time talking about some, I guess you would call word problems or applications to the mathematical concepts that we've been discussing, maybe more so than in some of your other classes. I hope that this is interesting to you. Maybe not this particular question, but that our class has more applications than maybe most. So in this particular example, this is an application to economics, which is a topic that we will be coming back to throughout the semester. So the purpose of this example is to, first, introduce a structure to these types of problems, including variables that we will use all the time for these economics applications, and also a couple formulas and some concepts. All right, so this question says, you would like to operate a lemonade stand at the New York State Fair. The daily cost of renting a table is $200 and it costs 75 cents to make each cup of lemonade. You decide to sell each cup for $2.25. How many cups of lemonade must you sell in order to, and then we've got a few different questions here. The first is to profit at least $200. The second is to break even. We'll talk about what that means. And then the third is to make a profit. Okay. So in these types of questions, and just looking at this question in particular, you notice that there are several different dollar values. It's important for you to understand which dollar value goes with like which party. So when you're looking at economics things, there's typically like a group or a person that is making something, and they have costs to make these things. And then you have another group or person who is buying their product, and that they buy at a price. Okay, so in this particular case, we have $200 and we have 75 cents. Right, those are costs that go with like you are the operator of the lemonade stand. You have to pay these things. Then the $2.25, right, that's the customer's price. That's what they're paying. Okay, so it's something to really be careful about kind of when you're reading these, is to recognize which party that these dollar values go to. All right, so to get us started, here are the economics variables that in general, this is going to be through all of these kinds of questions that we're going to want to be fluent in using and talking about. Okay, so this is generally what we are going to use for any kind of these questions. Economics variables. All right, so we're going, so variables in math means that it's something that can change. Okay, so in all of these cases, we are going to have an object that's being sold. And a lot of times you want to find like how many, like in this case, lemonade cups, must you sell in order to blah, blah, blah. And that can vary, right? So we need a variable that is going to represent the number of things or items that are made and sold. We like X. You can use whatever you want, but I'm going to use X in all of these examples, and that's the typical thing to use. So X will always represent the number of units, items, things, whatever the case may be in the particular question, that are made or sold. Okay, so in this case, again, X represents cups of lemonade. All right, our second variable, we need to talk about the cost for the producer, or for the lemonade stand operator, for you in this case. Okay, like what will it cost you to rent the table, and then also make each cup of lemonade, or make all of the cups of lemonade, depending how many that you make. Okay, so your total costs. Let's call that C, capital C for cost. So this is the total cost to the producer to make, now this is going to depend on how many things they make, right? How many cups of lemonade you make will affect your cost, right? If you make 1 cup of lemonade, you're only going to pay an additional 75 cents. But if you make 100 cups of lemonade, right, you're going to pay an additional, what, $75. Okay, so this is dependent on X. It's going to be a formula that has X in it. Okay, so it's the total number, the total cost to the producer to make X units, or items, or things, or whatever. Okay, we have a formula or a way sometimes that we can think about the total cost. So in most cases, the cost can be thought of as a fixed cost, something that doesn't depend on how many items are made or sold. For example, our $200, right? You rent the table, no matter how many cups of lemonade you sell, whether it's 1 or 1,000, you just pay that $200. It does not depend on the number of cups that you sell. Then we do have a variable cost, which is this 75 cents that goes with each cup. Okay, so we have to add on that variable cost. But not only that, that variable cost is going to need to be multiplied by how many cups that we make. Okay, so this is going to be multiplied by X, which again is so these will be number, and then X is going to stay as X in your equation for your cost. All right, we've got 3 more here. So we have a it's $2.25 is another monetary value in the question. That could be changing depending on the situation, right? So we're going to need a symbol to refer to that. So we're going to call this price, and that's going to be lowercase p. And I'm pointing it out because we will have an uppercase p. So I'm just drawing this like kind of cursive p with a little I don't know, thing at the top of it. And so it's going to be represent the price that the customer pays for 1 item. In this case, the $2.25. Okay, then we have, all right, you want to talk about how much money that you collect from your customers, right? That's something that changes. So depending on what your price is and how many items you sell, that will give you what is called your revenue. Okay, so we're going to call that capital R. This is revenue. Purely how much money that you collect that is in your, your cash register at the end of the day. So this is called your revenue. And it depends on how many items you sell. So this is going to, again, have a formula just like cost with X in it. So here's another formula for us to memorize. Or it should make sense the way this formula looks, right? It's how many things you sell, X, times the price for 1 thing, which is lowercase p. Number of things sold times price of 1 thing, right? That's how much money that you are going to collect. All right, then our last kind of variable here or symbol that we need is a symbol for profit. So here's an uppercase P. I'm just going to put like a foot at the bottom of it to distinguish it from price. Okay, so uppercase P will be profit. That's how much money that you actually have gained with your costs taken away, so that, because you have to take that into account to figure out how much you've made. All right, so profit for making and selling X units. right? Again, that's going to depend on how many items you sell. And then our last formula here is for profit. Okay, profit, well, it's how much money you collect, which is your revenue, or capital R, your revenue, and then take away how much money that you had to pay to create the product. Okay, so this will be revenue minus your costs, or R minus C. Okay, or if you like, R is X times little p, and then minus cost. They're all the same, whichever one makes sense to you. And that is it. So let's, so make sure that this is, I don't know, like highlighted or boxed or something like that. This whole section here is something that you're going to want to be really familiar with throughout this semester. Okay, so our first question is, I'm just going to make this a little bit smaller and move it so that we can kind of do some work maybe next to it. Okay, so for part A, it says we want to know how many cups of lemonade, right? How many cups of lemonade? So that's, we're looking for X, right? This is X, how many cups of lemonade must you sell in order to, and part A says profit at least $200. Okay, so profiting at least $200 in symbols, this means capital P is greater than or equal to 200. Right, that's what that means. Profit at least 200. That means in our symbols, capital P is greater than or equal to 200. So we're going to need a formula for profit in order to figure this out mathematically. Okay, in order to find profit, we need a formula for revenue, and we also need cost. So let's just go back to the beginning. So we've got X here. That's fine. We need to figure out what our cost function is. Okay, so for our particular situation here, our fixed costs, that is our cost of renting our table. So that's $200. And then the variable cost, or the cost per cup of lemonade, that's 75 cents. So this will be plus 0.75. And then that variable cost needs to be multiplied by X, just the variable cost. Okay. We have our little p, that's going to be the price for the customer, so that's $2.25. So now we can find our revenue function, or our revenue equation, so that's X times $2.25. Or a better way to write that might just be 2.25X. Okay, now we can find our profit function, or our profit equation. So this will be revenue minus cost. Okay, so it's 225X minus, now we're subtracting cost, and cost is a binomial. It's got two terms in it. So we need to subtract both of those pieces, right? We have this piece plus this piece. And so in order to make sure that we do that, we need parentheses around the cost function, or the cost equation. Okay, so this was revenue minus, we've got all of this, which is cost, in nice parentheses. And now a nice thing to do, since we're going to want to work with this, is to simplify it. And to simplify, a thing to do would be, well, combine like terms is a really nice way to simplify things. And we've got this X wrapped up in parentheses here, and this X over here. So let's just distribute this minus sign. So that'll end us up with minus 200 here, then minus 0.75X. And then we can combine our X terms together. So 2.25 minus 0.75, or $2.25 minus 75 cents. I think it's $1.50, or 1.5X. Okay, so here is our profit equation. Now we can actually use that. So in part A, we want to know how many cups of lemonade we need to sell to profit at least $200. So if we want to make profit to be greater than or equal to $200, right, that means that we want to set 1.50x minus 200 to be greater than or equal to 200. Now all that's left to do is to find the cups of lemonade, and that is represented by x. So we're just going to solve this inequality here for x. All right, so I'm going to add 200. We've got 1.50x is greater than or equal to 400. And we'll divide by 1.50 to get x alone on one side of the inequality. And you are allowed calculators in this course, so please take out your calculator if you don't have it out already, and figure out what 400 divided by 1.5 is. And this comes out to be 266.66666 repeating, so I'll just put a bar over the decimal like that. And let's interpret what this means. Like, you don't want to tell someone this, like what does this actually say? Right, the number of cups of lemonade that you must sell to profit greater than or equal to $200. You have to sell at least this many cups of lemonade, right? That's what greater than or equal to means. Now, if we have to sell 0.6 of a cup of lemonade, we kind of have to sell the whole thing. So I would kind of summarize this as saying, all right, well, we must sell, round up to the nearest cup of lemonade. So you must sell at least 267 cups to profit at least $200. I think that's probably doable on a hot day. Lemonade is very refreshing. All right, so part B asks us how many cups of lemonade must we sell in order to break even? Now that is hopefully exactly what it sounds like. So breaking even means that you don't profit anything, but you don't lose anything either. So in other words, your profit is equal to 0. Okay, breaking even means your profit is equal to 0, or in other words, your revenue and your costs are equal to each other. They just even themselves out. Okay, so in part B, what we want to do is find where our profit is equal to 0. All right, so here's our profit equation. We're going to set it equal to 0, and all we have to do here is solve for x. Okay, so we're going to add 200 to both sides. So we've got 1.50x equals 200. Okay, we're going to divide by 1.50. So let's see, 200 divided by 1.50 gives us 133.3 repeating. Now, rounding here, I don't know, it's a little weird. You can either round down or up. It doesn't matter much. I mean, if you sell 1 extra cup, you won't quite break even. If you sell 133, you won't quite break even. So, there's no real rule with this, in my opinion. So you can say one way or the other. So let's say we must sell, I'll just round down, 133 cups to break even. But if you wrote 134, because that makes more sense to you, then that is fine as well. All right, our last case here is how many cups must we sell to make a profit? Like make a profit at all. So we want to do a little bit better than breaking even. We want to not have a zero profit, but we want to have a positive profit. Okay, so making a profit means that P is greater than 0. Your profit is greater than 0. Okay, so let's go about solving that. I think it won't be that bad. Profit greater than 0. Okay, let's put in our profit equation here. Now we've just got a nice inequality to solve. So let's go ahead and do it. So let's see. Now, based on our answer from the previous question, you might be able to figure this out without any math, right? So that's okay, but we want to get used to using the formulas and the equations and kind of translating back and forth. So it is important to know how to do this as well. But it's good to have intuition about things, and your answers should make sense. Okay, so this is exactly like part B, except we've got a greater than here instead of an equal to. So I'd say, we must sell, 134 cups, because if we have to sell a third of a cup or 0.3 of a cup, then we have to sell the whole cup in order to actually reach the profit being positive. So let's say we must sell 134 cups to start making a profit. Oh, but that's not quite right. Let's say we must sell at least, right? That's important there. We have to sell more, 134 or more cups to make a profit. Okay, so you do have some questions like this on your written homework and on your web assign to practice for you, in this terminology and this language and these equations and kind of translating into math and back. So please take some time to look at those. And if you have any questions at all, please stop by office hours and I'd be happy to help you.